Hello, Farmer John here is just like the majority of Canadian farmers in the Niagara area, heavily relying on fertilizers and pesticides to maintain a healthy vineyard. But continuously monitoring the grapes is not an easy task, and then COVID happened and tourism completely stopped. So how can we use technology to help John reestablish the area's tourist attraction while facilitating his maintenance efforts? To help Farmer John grow sustainable crops, we're using Microsoft Azure's custom vision to quickly detect bacteria and fungi in grapevines and the grapes themselves. We've designed a user-friendly smartphone app that tells John the type of disease that the plants have, allowing him to quickly use the corresponding pesticides. Some diseases can also mean deficiencies in the soil, informing John to increase the potassium in the fertilizer. More importantly, switching to a data-driven system, John will be able to effectively use less pesticides and an appropriate level of fertilizer. Such technology helps John and fellow farmers to increase their harvest yield, lower their operational costs, and grow healthier and environmentally friendly grapes for us all to enjoy. These wineries with sustainable practices can then get themselves featured in the Great Taste of Ontario website, so tourists and local customers can access these sustainable products. And the following is the demo.
Images of the most common bacteria and fungi that affect grapes in Canada. We then uploaded the images to Microsoft Azure Custom Vision. Categorizing the images into their own different classes, it's important to keep in mind that the number of images in each category should be consistent. The image classification model, we differentiate between disease categories and the normal ones. Once all the categories are set, we train the images to create the model. We tweak the model and train it to get a reasonably okay result. For the purposes of this demo, the performance is good enough. Once the model is created, we check if it's working as expected. We check the model on a test image that was not used in the training, and as expected, it's good enough. We then export the model into a version that works with a smartphone app that we're building.
We have imported the model into a web app written in Flask and a Raspberry Pi viewed on a local host. Testing again works as expected.